Hello and welcome to a lesson on the graphs of cosecant and secant. The goals of the video are to graph the two functions, determine the domain and range of the two functions, and also to determine the period of the two functions. Now there are several ways to graph the cosecant and secant functions. However, remember that the following relationships are true. Sine theta is equal to y over r, and cosecant theta is equal to r over y. So they are reciprocals of one another. That's important. And secondly, cosine theta is equal to x over r, and secant theta is equal to r over x. So these are also reciprocals of one another. We're going to use these two facts to help us graph cosecant theta and secant theta. Let's first talk about y equals cosecant theta. Notice in gray we have the function y equals sine theta, and again remember these are reciprocals of one another. So what that means is we can take these values for sine, find the reciprocal of them, and that will give us the values of cosecant theta. So let's start off by taking a look at where sine theta is equal to 0. Remember 0 could be written as 0 over 1, and the reciprocal of 0 over 1 will be 1 over 0, which would be undefined. So where sine theta is equal to 0, cosecant theta is undefined, and that'll result in vertical asymptotes. So let's go ahead and sketch these in here. Again, where sine theta is equal to 0, cosecant theta is undefined. Next, let's take a look at where sine theta is equal to 1. Well, of course, the reciprocal of 1 is 1, so this point here would be on the graph of cosecant theta. The reciprocal of negative 1 would still be negative 1, so that would be a point on the graph of y equals cosecant theta. And now let's take a look at some fractional values for sine theta. For example, this point right here, sine theta is equal to 0.5 or 1/2. Well, the reciprocal of 1/2 would be 2 over 1, so this would be a point on the graph of y equals cosecant theta. Same thing here, sine theta is equal to 1/2, so cosecant theta is equal to 2 over 1. Right here we have sine theta equal to negative 1/2. The reciprocal of negative 1/2 would be negative 2. This is a point again on cosecant theta. Sine theta is equal to negative 1/2 here, so the reciprocal would be negative 2. So just from these 6 points we're getting an idea of what the graph of y equals cosecant theta would look like. Let's take a look at a couple more points. Let's say we take a look at this point here and say the y value for sine theta is 1/4. Well, the reciprocal of 1/4 would be 4, so there's another point on y equals cosecant theta. Again, if we assume this is roughly 1/4, the reciprocal value would be 4 over 1. And again, this function value looks like it's about negative 1/4, so the reciprocal would be negative 4, and same thing here. And that's enough information to make a nice graph of y equals cosecant theta. We have our vertical asymptotes. We have function values in between those vertical asymptotes. And we can make a nice graph of y equals cosecant theta. And in fact, we have completed the graph of this function over one period. And we can see the period of this would be 2 pi. Another way to look at this would be to use an animation from Wolfram demonstrations. Let's go ahead and take a look at that. What we're going to see is as this point animates around the unit circle, the function values for cosecant x will be graphed. Again, remember that since this is a unit circle, we're actually graphing the function value, which would be 1 over the y-coordinate. So right here, where the point would be 1, 0, 1 over 0 is undefined, and we see this vertical asymptote. Notice at pi over 2 radians, the y-coordinate is equal to 1. Therefore 1 over y is equal to 1. At pi radians is undefined again, and so on. It's not quite as easy to see as it is for sine and cosine because we're actually graphing the function value of 1 over the y-coordinate, or 1 divided by the y-coordinate. But there it is using the unit circle. Let's go ahead and summarize some facts about y equals cosecant theta. The domain would be any theta that is not equal to some multiple of pi radians, because that's where we have our vertical asymptotes. There are no x-intercepts. The function does have vertical asymptotes. The period is equal to 2 pi radians. The graph has no amplitude because there are no max or mins. And the graph is symmetrical with respect to the origin, and therefore is an odd function. Now let's consider the graph of y equals secant theta. Again, remember that secant theta is equal to 1 over cosine theta. So if we can find cosine theta function values, we can just take the reciprocal and we'll have the values for secant theta. So again, let's start off by taking a look at where cosine theta would be 0, because that's where secant theta would be undefined. And we see that here at pi over 2, which would be a vertical asymptote, 3 pi over 2, 5 pi over 2, and looks like negative pi over 2 as well. So what we'll do again is find function values for cosine theta and then take the reciprocal of those to find the value of secant theta. So again, where cosine theta is equal to 1, reciprocal of 1 is equal to 1. Next, we just need to find some values in here and in here. Let's start by taking a look at this value here where cosine theta is equal to 1/2. So secant theta would be equal to 2 here and here as well. Here we can see that the cosine theta is equal to negative 1/2. The reciprocal would be negative 2. There's our value for secant theta as well as here. And let's go ahead and fill in the values here as well. 1/2, reciprocal would be 2. And you can kind of see what's happening. It's very similar to the graph of y equals cosecant theta, except this is the reciprocal of cosine rather than sine. So the graph of y equals secant theta would look like this. And let's go ahead and take a look at a Wolfram demonstration to illustrate this as well. So as the point animates around the unit circle, we'll see the function values for secant x graphed on the coordinate plane here. Now we'll notice at the point 0, 1, since secant theta is equal to 1 over x on the unit circle, it's undefined, producing a vertical asymptote, and so on around the unit circle. And you can see the function values in red. So again, very similar to the graph of y equals cosecant theta, except it's a reciprocal of cosine rather than sine. Let's go ahead and summarize the key components. The domain is any theta except for theta is equal to odd multiples of pi over 2, because that's where we have our vertical asymptotes. The range is from negative infinity to negative 1, and from positive 1 to positive infinity, including negative 1 and 1. There are no x-intercepts. The function has vertical asymptotes. The period is pi over 2. The graph has no amplitude. And lastly, the graph is symmetrical with respect to the y-axis and therefore is an even function. I do want to talk about the graphing calculator just for a moment. We could plot function values using a t-table if we needed to. The way we would do that is, let's say we want to plot points on this graph here, which is y equals secant theta. There's no secant button on the calculator, so we would have to graph 1 over cosine theta, or in this case cosine x. Then it's easier to use degrees in the calculator, so we don't have to deal with decimal approximations from the table. So if we press mode, make sure we're in degree mode, make sure the table set is on ask, and then when we press second graph, we can type in any angle that we would wish. Again, this is in degrees just because if it was in radians, we'd have some decimals which might be difficult to recognize. And we could plot these values as well, rather than using just reciprocal values of cosine theta. So if you're ever stuck, you can always rely on the table feature of the graphing calculator to find additional points needed for any function. I hope you found this video helpful. Thank you for watching.